record on this. Do you watch any of these recordings?
I do. I've watched a couple.
Good, good. All right. Let me get this in two-pane mode where let's see, I guess I can get rid of that. I can get rid of that. I need this up there, and now we got it. Okay. So, since we're dividing a quadratic by binomial,
which math Excel is this?
oh yeah, it looks like you've already done this problem.
Yeah, I think I've done all of these.
Okay, where do I need to go?
There should be a save button on the right-hand part of math Excel.
Mm-hmm, yep. There is.
And
now enter again.
mm-hmm.
Then when I hit enter, you notice it's doing something weird.
Yeah, it is.
I mean,
try refreshing.
Yeah, well, yeah, it's acting weird here. It's opening up another window. Let's see what this window is. Stay on this page. It's giving me that, in other words, whenever I enter, it's taking me to this problem. How about if I hit some of these keys? Will that get us to where we need to go?
Well, it
First
should
of all,
when
do you need to review that as to how they got that answer?
No, I've got that down.
Okay, that's long division. And the only reason I know it's going to be long division is because I see a remainder. So we might have tried factoring that and see if we got a factor that was 1 plus 2y. But clearly it isn't, because otherwise we wouldn't have a remainder. So
right.
Let's see. If I hit one of these buttons, what happens?
It just takes it to the other problems.
And you've done all of them.
Mm-hmm.
Okay. So do we want to go to 11.4?
We want to go to 11.7, I believe.
Now, how do I get there is the question.
Try hitting save one more time.
Okay.
That should take you back to the home screen.
Which it did. Should I? No, we've already logged in.
Does it just automatically take you to 11?
Yeah. I tell you what, let me log out and let you log in, and you can just read the problems.
Okay.
Will that work?
It might be a little bit harder with... Yeah, I think it will.
Okay. Well, only reason I say is because I don't want to waste our whole half hour with me trying to log in here. There seem to be problems, but let me make sure I log out. I guess I can just close out. Okay, I should be logged out. Why don't you try logging in?
Okay, it's taking a second. $11.7, okay.
Okay. What's the first problem? What nature is the problem?
It's f of x equals 3 over x minus 1. Actually, wait, I can... Okay, never mind, I just answered that. That was pretty easy.
Okay.
It was just...
And then they wanted you to know what is f of 2?
It wanted just to know what the excluded value is.
Okay, what is the excluded value? What's the restriction on the domain?
The denominator is x minus 1.
Which means that can never be 0. So x cannot be 1. That's
right.
the only restriction. X can take on any value of the number line except 1. You can never divide by 0.
Right.
What else?
The next one is identify the horizontal and vertical asymptotes of the graph to the right.
Okay. Oh, I see. And they give you the graph?
Mm-hmm.
They don't give you the function?
They do not.
Okay. The vertical asymptotes, here, and let me show you how you're going to do this. If the function was 1 over x, that has a vertical asymptote at x equals 0, right? Because x can never be 0. And it has a horizontal asymptote at y equals 0. And the function looks like this. So if they were to give me a function and say, where are the vertical asymptotes, well, I can tell where it is. In other words, there's one spot that the function never crosses. The function, it's impossible for a function to cross a vertical asymptote. So look at that graph and tell me what vertical lines are not being crossed by the function.
1,
X equal 1.
x equals 2 and y equals -1.
Hold on. For vertical asymptotes, it's always x only.
Right.
So you're saying there's a vertical asymptote at x equal 2?
Correct.
And then there's a horizontal asymptote at x equal 1.
-1.
-1. Okay, so if I were to try to draw this graph like that, there's my vertical asymptote at, you said x equal 1 or 2?
2.
And then the horizontal asymptote is at y equal -2. Now, horizontal asymptotes can be crossed. There's nothing that prevents the graph from crossing the horizontal asymptote. But you can still see where it is. The horizontal asymptote is the end behavior. In other words, as you go to infinity on the x-axis, what does the y value approach? And your curve should show you that it approaches the line y equal -2. In other words, you might have a curve like this.
Mm-hmm.
Is that something what the curve looks like that they gave you? Whoops, hold on, I didn't draw that quite correctly on this side of it. In other words, it's always going to be approaching the vertical and the horizontal asymptotes. And notice that as I go to infinity on the x-axis, my y value is approaching my horizontal asymptote, -2. And as I go to negative infinity on the x-axis, my y value is also approaching that same horizontal asymptote at -2. Okay? Now, there is one other thing I can do here, and that is switch presenters. I can make you the presenter so that I'm seeing the curve.
Mm-hmm.
You have more problems where you have to interpret a graph?
Yeah, they're all that way.
Let me make you the presenter then. And we'll be looking at your desktop. Now the only thing I have to do is figure out how to do that.
Yeah, I think
Go to meeting. Can you make James the presenter? Go to meeting menu. Wow.
there's a button right here that says show your screen, and that's when I clicked that, it sent the message.
Okay, but I think hold on, I'm muted. The old GoToMeeting, when I had my old operating system, used to give you a button to make somebody else the presenter. When I click on that, can you make me the presenter?
It keeps sending it every time I push this.
Hit reply. Did that do anything? Oh, I bet if I click on your attendee, here we go. Make presenter. Okay. Are you sure you want to make James the presenter? Yes. Okay, now we're both going to be looking at your screen in a minute. Okay, now can you put those graphs up on your screen so that we're both looking at them? May take a minute.
Can you see my screen?
Well, not yet. It says waiting to view your screen, so it's going to take a second. So it's one of the reasons I don't particularly like switching it is, okay, now I'm seeing your screen.
Okay.
And that problem you gave me was A? Oh, no. Oh, this is the next problem?
Oh, right. The original problem was off this worksheet I have next to me.
Okay.
Until Math Excel loaded.
Okay. So let's look at, this is number 3, right? You have to do this one?
Mm-hmm. I started working on this one in class earlier.
Okay. Where's the vertical asymptote? Always start with the vertical asymptote.
The vertical is going up and down, and that's on x equals.
X equal what?
X equals 4.
Uh-huh. Because that's the one thing that'll make the denominator 0. So we want to pick whichever curve has a vertical asymptote at 4. And it's not clear to me which it is. I see, because they're all gridded funny. Yeah, everything is 2 units. So we got a lot of choices. In fact, all 4 of these graphs, not B, but A, C, and D, each have vertical asymptotes at x equal 4. But where's the horizontal asymptote?
Y equals 0, so it's just a flat line at the 0.
And the only one that does that
Is D.
Correct. Now, actually, both A and D have the correct horizontal and vertical asymptotes.
Oh, they do.
They do. The difference, though, is that on A, it's in kind of the first and third quadrants, whereas D is the second and fourth quadrants. So to tell which one it is, plug in a value to the right of that asymptote. And let's see what number we get. Pick a number to the right of 4.
Okay.
Plug it in. What's
5.
y? Okay, what's y equal to?
Y equals 3 over 1.
Okay, that means is that when I'm to the right of that asymptote, I have to be above the x-axis, because you're telling me that y is 3 when x is 5. That doesn't fit picture D. That only fits picture A.
Right.
And that's how you tell as to which quadrant you're in. In other words, it's not just about finding your 2 asymptotes. It's about determining if you have the hyperbolic function, which is what these are, in the correct quadrants. Okay, so this one, where's their vertical asymptote?
That would be 2. And
Are
this
they
would
going
be...
to make you say x equal to?
Oh, you probably just saved me from getting it wrong. They do make you do
the vertical asymptote is the equation of a line, and 2 is just a point. Okay. Now before you go on to the next one, don't click that. Okay, that's all right. Let's do this one. That's fine. Now, in order to figure out that graph, we got our asymptotes correct, but so it's either A or C, right?
Right, from graphing our asymptotes.
How do we figure out which one? Notice that A is what I call the first and third quadrant. C is the second and fourth quadrant.
Right.
So how did we figure it out before?
We picked a value that was greater than the
Than the vertical asymptote.
The vertical asymptote.
because that's the x measurement. So pick
So you have to pick a
a
value
number
bigger
bigger than x equal 2.
So x equals 3, and then we plug it in.
Okay, and then we'll figure out what y is, or what f of x is when we plug in 3 for x. What do you get?
-1.
Plus 4,
Plus 4.
which is plus 3.
Plus 3.
That means I can't be over here. In other words, oh yes, I am over there, rather. In other words, it's got to be this curve here, because when I go to the right of 2, I'm less than 4, right? I'm not
Right.
greater than 4. In other words, had you come up with an answer of 5, that means it would have to be A, because that means that when x is 3, y would be 5. It would have to be this curve here, not this one over here. In other words, this is telling me that as x gets bigger than 3, y is always going to be less than 4. That's what this curve tells me.
Right, so now we know y is always going to be less than 4.
And that makes this the proper curve, not A.
Right.
Okay. And just as a matter of principle, usually when you have negative signs in the hyperbolic part of the function, that's going to make it not in the first and third, but usually in the second and fourth, like that last problem. And I would bet anything that this is going to be the same thing. So go ahead and put your vertical asymptote in there. Okay, and your horizontal asymptote is what?
Y equals plus 4.
Correct? Or just y equal 4. I'm not sure what they'll do with that plus. You never can tell with Math Excel. Okay,
Right.
so we know our asymptotes. -3, which looks to be, all of them have -3 maybe not over here. That looks like more like -5.
So it's not going to...
Yeah, it looks like this one right here is the -3 vertical asymptote. Now, hold on, before you click that, that also has a horizontal asymptote at 4, but I think this one also has those same two. So we have to decide between A and C. In other words, doesn't A also have a vertical asymptote at -3? 1, 2, 3. Yeah, it does. And it has a horizontal asymptote at 4. So let's go through that process again. I'm guessing, if I had to guess, and I don't like guessing, but if somebody said you have to answer in 2 seconds or I'm going to blow your brains out, I would guess this one over here because of that -3 on top.
Right.
Let's do it properly. Fill in a number to the right of your vertical asymptote. What's the easiest number to pick?
5.
How about 0?
Okay, 0.
All it has to do is be to the right. In other words, we're picking this value right there for x. And when you plug in 0 for x, what do you get for y?
1.
You get -1 plus 4, right?
Mm-hmm.
So you get a +3. Is that +3 right there?
It
is not, but it is over here. In other words, when I go to x equals 0, y is +3, which is what we get when we do the algebra. So it's got to be C. Make sure you're clear on how we're doing that.
Right. So,
in other words, we're plugging in a number to the right of the vertical asymptote. We could have plugged in -2, -1. 0 is always the easiest one to work with. When you plug in 0 for x, you get -3 over 3, which is -1, plus 4 gives you a plus 3. So y has to be plus 3 when x is 0. And it's not in this picture over here, but it is in this picture here. That makes this one the correct one.
Ah, I see that now. That should be
They're always going to give you two graphs that have the same horizontal and vertical asymptote. It's clear to me that they're doing that on every one of these, including this one. Now, what's the first thing we notice from looking at that equation? How many vertical asymptotes are we going to have?
We're going to have 2.
Correct. So the answer has to be what? Either what or what? There's only two graphs that have two vertical asymptotes.
It's either going to be A or B.
Correct. Okay. They both have horizontal asymptotes at y equals 0. So let's do a similar test. What's a good number to plug in for x?
1 would be the easiest.
How about 0? Notice 0, if the answer is positive, this is the answer. Yeah, I can plug in x for 0. Remember, you can't divide by 0. But I wouldn't be dividing by 0. If I plug in x for 0, I'm going to be dividing by minus 8. Right? I got minus 2 times a plus 4. That's minus 8. So y is minus 5/8 when x is 0. Which graph is that?
So when x is 0, y is 5/8.
Y has to be negative.
Right.
It's not that graph.
C.
Oh, no, hold on. Unblock
B.
B. And blow that up. Just expand B. Notice that when x is 0, y is negative, right?
Right.
And that's what we calculated. We calculated minus 5/8. So it has to be this one.
This is where y crosses the x-axis.
Right. It all depends on whether y is really above your horizontal asymptote or below your horizontal asymptote. And in this problem, since the horizontal asymptote was at y equals 0, we merely needed to figure out whether y was positive or negative when we were between those two asymptotes. And no matter what value we would have plugged in for x, we're going to get negative for y. Whether I plug in minus 2, minus 1, 0, I can't plug in minus 2, but
anything other than the excluded value.
Oh, that's minus 4 and plus 2. Yeah. I hate it when they change the grid on you on every problem.
Yeah.
I mean, wouldn't it be better if the grid was always the same, 1 unit or 2 units even? But on some of them it's 1, on some of them it's 2. So you have to be a little careful of that. But, okay. Go ahead and close that one out.
All right, that's the last of these problems.
Okay. Actually, we're done. So it's a good place to stop. Finish those problems.
Okay.
Oh, I just realized you can't see my screen. It's not visible. And then I realized, oh yeah, we did that on purpose. So let's see. Let me go back here, make sure I can change the presenter. Well, I guess I can always just close it out. I don't see. Oh, dismiss James Andrews. That might actually, oh, I know how to do that. No, I don't. Anyway, you can close it out. I'll close it out. Everything will be copacetic. So our next meeting is next Tuesday online.
Hey, Mom?
Yeah?
Did we schedule a meeting on Sunday?
I don't have one on my calendar for Sunday. That's why I asked.
Not yet.
Okay, I'll just let you take care of that then. So the next meeting I have scheduled is at 4 on Tuesday online.
That sounds good.
Okay, sounds good. Talk to you next time, James.
Sounds good.
Bye-bye.
Bye-bye.